Hey everyone, in this video we're going to finish activity 1.1 which we started in a previous video. We're going to look at an equation to represent this relationship between female students and total students or whatever they've given us. We're also going to look at a way to graph it and represent it graphically in this situation. So we're going to start off with the equations. This is on page 10 of your book, M2-10. It says choose the correct equation to match each description. Then we'll compare them at the end. So letter A, it says the number of female students enrolled, Y, for X total number of students enrolled. So female to total. We saw back in the getting started back on page 8, this was actually number 1 on page 8, female students to total. We know that that is a ratio of 3 to 5. So if you just look at all these equations, I think that knowing that ratio is helpful. Look at these equations. This one sticks out to me because it has that same ratio in it. So this is actually the equation that matches this description. For part B, the number of male students enrolled to the total. Well, male students to total we saw was 2 to 5. So again, looking through these equations, I see this one right here has that ratio in it. C, number of female students to the number of male students. So female was 3, male was 2. So the ratio I'm looking for is 3 over 2, which is right here, or y equals 3 halves x. For D, they've just flipped this around. Number of male, y for x female. So number of male was 2, female was 3. So I'm looking for 2/3 is my ratio, and there it is. So now let's compare these things. What are some similarities between all these equations and the ones that we chose? What are some differences? To me, the biggest similarity is that they all kind of look the same. Besides the number in front of x, they all look the same. So the equations are in the same form, and that form is y equals something in front of x. So some number in front of x. I'll just use a for that number. So they're all written in the same form, y equals x. The difference is whatever that value of a is. The difference between the equations is the value of a in each equation. It's really the only thing that changes. Some of them have something added at the end, so we can add that, and some of the equations have a number added to the end of it. But really the biggest difference is that number in front of a. So now we're going to move on to graphs. So we're going to graph each ratio that they describe, and then we're going to compare them. So in part A, I'm now on page M2-11 of your book, so please do this with me. M2-11, total number of female students enrolled, Y. So that's why I labeled the Y-axis the total number of female students, because it told me that was Y. With respect to the total number of students enrolled, X. So that's the X-axis. So go ahead and copy the labels down, and I'm going to number these also. I'm going to make each square worth 1, but I'm going to label just every other. So I'm going to start here at 2. So just copy this with me. The labels and the scale and the numbers. So this is 1, 2 starts here, 4, 6, 8, 9. This would be 10, 12, 14. Is that right? 2, 4, 6. Yep, I think that's right. All right. So here we go. Let's graph this relationship. Total number of female students to total number of students. So female to total number of students, we know that was in this ratio, 3 to 5. So for 5 total students, 3 of them were girls. So we can actually plot that point. 5 total right here. 3 of those are girls. So that would be this point right here. And actually, if we were to flip back at some of the pages where we use this same ratio, on page 9, problem number 1, part A, it said if there were 15 total students, which would be here at the end of our graph, we used a proportion to determine that 9 of them would be female. So 2, 3, 4, 5, 6, 7, 8, 9 of them would be female. So there's 2 points that give us an idea of what's going on. We could probably throw another one in there. If there are 0 number of students, obviously 0 are female, right? So that gives us an idea of what's happening here. And actually, we could draw a line through these points, and then anything on this line would be in the same ratio as these female students to total number of students. And I think my point's off a little bit there, so let me just fix that point. There we go. So that line represents this description. Let's do the same thing in part B for male students. So go ahead and copy all of the labels again. This time male students is our Y, and total number of students is our X. And you can put the numbers in there also. So again, we'll just do every other. Let me make my marker smaller. Feel free to pause the video and come back to this. All right. Well, we know the ratio of male to total, going back to the very beginning of this lesson, was 2 to 5. So let's graph that one. Every 5, so if there were 5 total students, 2 of them would be male. That's right there. We actually saw in the table on page 9 that when there were 0 total students, that means 0 males, right? 0 students, 0 males. So we kind of have an idea here of what it's going to look like. Let's go ahead and draw the line like we did for the female one. So from this point through this point, I'm actually going to extend it, right, like that. And that means when there are 15 students, it looks like 6 of them are male. So 6 male, 15 total. That means these things have to be equal. We could quickly check that just by doing cross products. 2 times 15 is 30. 5 times 6 is 30. Those things are equal. That works. So that line represents number of male students with respect to the total number of students. So now let's compare them. Describe similarities and differences. Look at both of those graphs in your book. What's the same? What's different? Take a minute and write down what you think is the same and what you think is the different. Then pause the video and come back. So what I noticed, let's start with similarities. First of all, I noticed both of them form lines. So both graphs are represented by lines. And I also noticed they both go through the origin, which is the point 0, 0. 0 total, 0 male. 0 total, 0 female. So that's what I notice is similar about these graphs. I'm not talking about the labels or the scales. I'm actually talking about the actual data in here. So both are represented by lines. Both go through the origin. I would say the difference is that one of them looks steeper to me. The female one looks steeper. So the difference is that the graph for females enrolled is steeper. All right. So let's kind of wrap this up. In this lesson, we've been studying relationships that are proportional. A proportional relationship is one in which the ratio of the inputs to the outputs is constant. I would like for you to highlight that or underline it, please. So proportional relationship means constant. The ratio is constant. For example, a ratio of women to men was always 3 to 2. Proportional relationships are always written in the form y equals kx, where x represents an input value, y represents an output value, and k represents some constant that's not equal to 0. I just want you to underline the first part of that. Proportional relationships are always written in that form. This is the form proportional relationships are written in. Y equals kx. I used a earlier. K is the same thing as that a I used earlier. And then the last thing I want you to know is that this constant k is called the constant of proportionality. Those who had me last year in 7th grade, we used that term last year. Constant of proportionality is that coefficient in front of x. So let's go back to question 4. Turn to page 10, just the next page over, and the constant of proportionality for each of these. So let's do this. Let's just kind of summarize. So part A, the constant of proportionality was 3/5, right? So in A, it equaled 3/5. For part B, the constant of proportionality equaled 2/5. For part C, the constant of proportionality in that equation was 3/2. And then for part D, it was just flipped around. It was the reciprocal of part C, should be 2/3. So again, these all tie to the equation that we chose in part 4 right here. These equations. It's just that coefficient, that number in front of x. Identify the constant of proportionality for each graph in question 5. So there were two graphs, right? There was the female graph, there was the male graph. So let's look at the female graph. So the female graph looked like this. We first plotted this ratio, right? 3/5. This right here is our constant of proportionality. So for the female graph, that constant of proportionality was 3/5. And anyone remember what the male one was? If I scroll back up there, I think it was 2/5, wasn't it? 2/5 was the ratio we started with right here, represented that point right there. So constant of proportionality for the male graph was 2/5. And that wraps up different representations of proportional relationships. In these videos combined, you saw a graph, you saw equations, you saw a table. We also saw how to use a proportion to solve, or how to solve a proportion using the ratio at the beginning of the lesson. So lots of stuff in this video. Please let me know if you have questions or if we need to clarify anything, but I think this video would be very, very helpful. Hope you guys have a great day.